So the next topic what we are going to discuss here is binary search tree. Binary search tree. In short form, we will call it as BST. BST stands for binary search tree. See what is mean by this binary search tree. So how this binary search tree is going to work. See the basic thumb rule is very clear, sir. So whether it is a binary search tree or any other tree, some properties will be there. Whatever property is there for binary trees, same properties will be there. I can say binary search tree is also a tree. Is also a tree. That means what properties are there for tree, same properties will be there for binary search tree also. This is very important thumb rule what you need to understand. Sir, after this, what speciality will be there? So in addition to this, what speciality we are going to get? So let us see binary search tree is also a special tree. Binary search tree is also a special tree with some special properties. Binary search tree is a special kind of tree with the following properties. What properties will be there? The first property is nothing but elements which are existed in the left subtree. Okay, in the left subtree of binary search tree are less than root node data. If you take root node data, all the elements present in the left side of this particular tree must be less than. Sir, what about right subtree? The elements which are present in right subtree, so elements which are existed in the right subtree of binary search tree are greater than root node data. So what about next one? Sir, what about equal? If two nodes are equal, then how you can say? Sir, no duplicates no duplicates are present or no duplicates are existed, like that we can say. I will give you some examples, then only you will get more clarity. See, consider there is one tree with elements 3. Okay, what is its left child? Assume that it is a 1. So what is its right child? Assume it is nothing but a 7. Guys, tell me, is it a tree or not? Please confirm. Is it a tree?
Yes.
Everyone please respond. Is it a tree?
Yes, sir.
Yes, it is nothing but a tree. It is nothing but a tree. So is it a binary tree?
Yes.
Is it a binary tree?
Yes.
What is the speciality of this binary tree? Can I say at most 2 children should be there? Correct?
Hmm.
So we have 2 children, right? At most 2 children are there. Correct?
Yes.
Yes.
Can I say is it a binary tree or not? Yes.
Yes.
Is it a binary search tree?
Yes.
Yes. So what is the additional properties that we have for binary search tree? The nodes which are present in a left side must be less than root node. Sir, is it less than root node? 1. Yes. 7 greater than root node? Yes. Now I am taking one more example like 3. So left side I am taking 4, right side I am taking so 5. Okay, and one more node I am taking like 6. Tell me, is it a tree?
Yes.
Yes. Is it a binary tree?
No.
Yes.
No. No. Because for binary tree, how many children? Either 0 or 1 or 2. Sir,
Two.
if it is not binary tree, definitely it is not binary search tree. Correct?
Yes.
Suppose consider we have 3 is there. Its left child is 4 and its right child is a 5. Is it a tree?
Yes.
Yes. Is it a binary tree?
Yes.
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 Tree, binary tree.
Is it a binary search tree?
No.
No.
No. Got it?
Mm.
Sir, can you please take a big example? No problem. If you take a tree called 4, assume left side 2 is there, right side 6 is there. For 2, left side I am taking 1, right side I am taking 3. So for 6, left side I am taking 5, right side I am taking 7. Listen carefully. This rule is applicable for every internal nodes also. 1, is it less than 2? Yes. 2, 3, is it greater than 2? Yes. 5 less than 6, 7 greater than 6, then 2 less than 4, so 6 greater than 4, like that. So it is a tree, it is a binary tree, it is a binary search tree. So remember carefully, whenever we have a tree, it will always execute from the bottom. Got it, friends?
Okay.
Mm.
Sir, in the third scenario, why it's not BST?
Madam, in the third case, the elements which are present in the left side of the node, 3 left side is nothing but what?
Okay, 4. It's greater
It
than
is,
3.
yes,
Yeah,
it is
yeah,
greater
yeah,
than
yeah.
3. Got it?
Okay. Yeah.
Clear, guys?
Yes.
Sir, if I want to insert any new node, for example, I want to insert one node called 8 into this particular tree. Can you please tell me where we have to add this?
After 5, after 7.
After
7 at left
So,
side.
yeah,
Right.
can you please confirm? Can I add this node? Okay, can I add this node left to 1?
No.
No. Right to 1?
No.
Oh,
No, because right to 1 we can take, because 8 is greater than 1, but it is less than 2, no, right?
Yes.
So left side of 3, right side of 3 is also not allowed. Left side of 5, right side of 5 is also not allowed. Left side of 7 is not allowed, but we can attach here. Am I right?
Yes.
Can you please tell me the same thing where we can add 8 in this binary tree? Can I add here?
No.
Yes, we can add. What is the problem? It is
Uh,
not binary search tree, right?
Yes.
Can we add
Anywhere.
right side of 4? Anywhere.
yes.
That's why I didn't covered insertion of a new node into binary tree. Why? Because there is no proper style. Got it, friends?
yeah, yes, sir.
Sir, everyone understood. Some people are asking the question like this: why can't we perform insertion and deletion operation in binary trees? Why you didn't covered? Why? Because in the binary tree, so we can't add the elements, we can't remove the elements. Why? Because there is no format. If there is no format, how you can? Not possible, right? Sir, everyone got it?
The format means what you are telling me?
That rule is not there in binary tree, right?
Like removing like at since if it is at most 2, so anything less than 2 is fine.
We can remove, but we have to perform search operation also there. Where it is available, we have to go.
Okay, yes, yes.
Of course, we can do removing, but we can't perform adding. Removing also, it is not direct part, right? We have to do search operation, then we have to write the removing. First of all, if insertion is not possible, then think about removing.
Yes.
Clear, guys?
Yes, sir.
Right. So now the first we will go for implementation directly. Up to this, I think there is no doubt, right? Again, I am asking. Up to this, no doubt, right?
Sure.
No.
No.
Right. So now coming to the implementation of binary tree, first we will take at a very top level. Okay. So then after break, we will see in detail. Sir, the first operation, let me go for insertion. Insertion of a node into binary search tree, because this is my important operation. After insertion only, you can do n number of things. Sir, in the program, I will do some small modification, friends. What is that modification is, instead of, sir, can I take node as it is? There is no disturbance, right? Instead of B tree, I will take BST. Clear?
Hmm.
Root node is always null. So I don't want these orders. Okay, let us take only in order. I don't want remaining, or let me take in order and then level order, and remaining all the implementations I am removing, not required. Okay. So initially there is nothing. So I want to do insertion operation. First, let me write the main program. Binary search tree, tree is equal to new binary search tree. In the previous case, directly we added. Now, so tree dot, I am calling in order function. I am calling in order function. In order function like this. So tree dot, I am passing the node. Let me print the message system dot out dot println of. So in order of the tree is nothing but like this we have. I am not using print element like this. Please be on mute. Please check the surroundings. These sessions are being recorded several times, I am telling. Now there is no nodes right as of now. If I execute, what will happen? Invalid method declaration. Sorry, the constructor name we need to take like BST, because so is there any elements in the tree? No, that's why it is printing in order as a empty. Now, sir, I don't want to insert in the program like in the previous example we have taken. So tree dot root is equal to something like that we created. I don't want that. I want tree dot insert node of, I am going to pass it to. So what that insert function is going to take? That insert function is going to insert the node. So void insert node, void insert node I am taking. So integer data it will take. Sir, I am telling it is utility function. It is a utility function. So why it is utility? Because to make the user to feel free. Now what I will do is root is equal to, again I am calling insert node by passing root comma data. I want to attach that to root. So now I will write overloaded version of insert node. Now same method name we can take. Now it is receiving two parameters. What is the first parameter? A node, and the second parameter is the data. Now we have to insert. Up to this, any queries? Why I have taken two things? Because this parameter I don't want to pass from the main to avoid the confusion. If you are clear with this, then I will start writing the code. Any questions?
No, sir.
Sir, everyone please confirm. Clear arm?
No, sir. Why can't we take recursive here?
Why recursion, madam? Is there any common pattern? No, right? Anyway, we will take recursion, but we have to see why I am taking two methods. That is your confusion, right?
Yes.
If I take this method, insert node, not only it is doing insertion, it will return something which is nothing but a node. That node we have to attach to root. Suppose if there are multiple levels are there, every time whenever you are doing insert, it should add to the appropriate position that reference we are assigning to the node. This work we can't do in the main program. We can do, but every time we have to write like a tree dot root is equal to tree dot insert of something like that. So like tree dot root is equal to, so tree dot, so insert node of, okay, again, so tree dot root comma data, that is nothing but 2. So you can see 65, 66, which line is very easy for user point of view? 65, right? That's why. Got it?
Yes.
Now, sir, first time, what is the value of node? Anyone tell me what is the value of node initially? Can I say,
2.
is it null?
Null.
Initially it is null, right? Then
Yes.
we called insert node. It will go here. Now insert node we are calling root. Root is initially what? Null only, right? So now what will happen if the value of node is equal to null? So what we have to do? Can I do node is equal to new node of with the given data? Correct? After this, return the node. So in this example, I got one node. What is the name of the node? The node content is nothing but 2. Sir, I am not taking the references to get avoid confusion. Now this will be written to for what? Root. Clear up to this?
Yes.
When this will happen? Very first time insert operation. Correct? Now, so what is my next operation? Sir, if node is not equal to null. Sir, now I want to insert one more node. What is the next node that I am supposed to insert here is, I want to insert 1. I want to insert 1. Now observe, is root node is equal to null? No, right? This is node, correct? Is it equal to null? No.
No.
Then it will come to else. In the else we have to check. How to check? Sir, if the data which you are trying to insert, which is nothing but 1, is it less than node dot data? Tell me friends, is it true or false? Data which I am inserting is 1. 1 is less than, node is nothing but 2. Its data is 2. 1 is less than 2. True, right?
Yes.
Then what will happen? Node dot left is equal to, can I call again insert node of node comma, what is the data? The data which you are passing. But it is not for node dot left. So it will create one more node. Sir, is node is equal to null because its left child is null, right? Yes. Now we are inserting this node where we are attaching this one node dot left. Got it? Return that node that will be attached to 2. Now I want to insert one more number which is nothing but 3. Is node is equal to null? No, because pointing to 2. So is the data 3, is it less than root node data? No. Then what we have to do? Go to else part. In the else, you know the code, recursive code. Node dot write is equal to insert node of node dot write comma the data which you are inserting. Can I say one more node will be created with the content 3, where it will be attached to the right side of 2? It is already null, so we are just attaching here. Got it, friends? Any queries?
No.
Right. Now let me check really what is the in order for this. Anyone tell me?
Two,
What is the
one.
in order for this?
1, 2, 3.
1, 2, 3.
One.
Is it properly inserted?
Yes.
Now my question, I want to insert. Okay, I want to insert 4.
Hmm.
First it will compare with 2. Correct?
Hmm.
Is it less than 2? No. It is greater than 2. Node dot write of insert node. So node dot write. That means now node will become what? 3. We are inserting. So now again it will compare with 3 because it is a recursive process. Is node is equal to null? No, sir. The data which you are inserting 4, is it less than 3? No, sir. Is it greater than? Yes. Now its right side is null, right? It will create here. Got it?
Hmm.
Now, if you want, you can check what is the in order now.
1, 2,
Maybe if you are getting
3, 4.
confusion, better to take level order so that easily you can able to understand. So level order, like this I am taking. Now observe, it is a method name, level order traversal. Correct?
Hmm.
Sir, everyone clear up to this?
Yes.
Now observe, if I am inserting 5, where it will be inserted? Tell me.
Right of 4.
Right of 4. Can I say it will be in the next level?
Yes.
Correct?
Hmm.
Now assume I am inserting something like everything we have inserted already. Now I will do one thing. So here I will take 8. Here I will take 8. So that this 4 and 5 will come. Here 4 and here 5. Correct?
Hmm.
So if I add 10, it will come here. Correct?
Yes.
So 2, 1. Then I will insert 8. After that 4, 5. Then I am supposed to insert 10. Now see what will happen. 2, 1, 8. So 4, 10, 5. Now let me try by inserting 0. Where it will come? Less than 1.
Left.
Correct? Everyone clear?
Yes, sir.
Any questions?
No.
So this is the way how to perform insertion operation into binary search tree. Sir, it is very easy operation. Okay, you can practice by taking multiple examples, then only you will get a clarity. Sir, clear?
Hmm.
No. So before moving to the next example, I will insert some notes here like 6, after that 4, 2, 5, 1, so 3, 8, 7, 9, 10. Let us see how it will be. So root node is nothing but a 6. Okay. Its left child is 4. Again 2. It is a left of 4. Again 5. 5 is a left of root node, that is 6. Okay. And is it less than 4 or greater than 4? Greater than 4. So it will come here. Am I right?
Yes.
Hmm.
Then 1 less than 6, less than 4, less than 2. So it should come here. So 3 less than 6, less than 4, greater than 2. That's why it will come here. 8. So greater than 6, it will go here. 7 greater than 6 less than 8, it will come here. Greater than 6 greater than 8, it will go here. So greater than 6 greater than 8 greater than 9, it will come here like that. Let me check, really is the tree whatever I visualized, is it the same tree is coming there? 6 4 8 2 5 7 9 1 3 10. Yes, perfectly in proper levels it is printing. Any queries?
No, sir.
No, sir.
Now I want to perform search operation. I want to perform search operation. Search operation in binary search tree. Sir, it is not like search operation what we are doing in binary tree. Why? Because if you want to search for any element, suppose consider system.out.println of, see, I want to search. So the number called 9. So how to search bst dot? I want to implement a search method which is going to take 9 as the parameter. My expected output is true. Assume I am searching for 11. My expected output is false. My question is, if I want to search for 9, first we will compare with root node. So if it is equal, the result we got. If it is not equal, then we need to search in left part or right part, we will decide. Suppose if it is in right part, we will never come to left part. Correct, sir?
Yes.
Now I will implement in a normal manner. Let us see how it will be. So I am taking one static method. The return type of the method is Boolean. Method name I am taking search. It will take some integer value. So node, current node is equal to, I am taking root until current node is not equal to null. Sir, until root node is not equal to null. If the value which you are searching is root node data, means simply return true, saying the result we got. Otherwise, if the node which you are searching is less than current node data, means so current node will become what? Current node left. Otherwise, current node will become what? Current node right. Like this we have to take. So at last what we need to do? We have to return false. Got it? Any explanation is needed? So first time when you are searching for 9, this is nothing but current. Is the value is equal to current dot data? No. Is value is less than current node data? No. Yes. Sorry. No. Then what will happen? It will go right side. So now current node will become 8. Is the data is matched? No. Is the value which you are searching, is it less than this node? No. Is it greater than this node? Yes. That means go here. This will become current. Sir, is 9 is equal to the current node data? Yes. How many comparisons? 3 comparisons. Suppose if it is not binary search tree, it will compare all the left side elements, and while coming to the right side at almost last but one comparison, you will get the results. So that is nothing but the problem what we have. Clear, guys?
Yes.
Is the search operation is clear?
Yes, sir.
What will be the time complexity for this?
You have to tell, sir. What will be the time complexity?
Big of O log of n.
That's all, simple. Okay. Non-static variable, non-static variable. Yes, 9 is available, true. So what is that number I have given? Sorry, here I didn't update it. So 11 is available? No, false. This is the way how search operation is going to work. Any queries? Clear?
Yes, sir.
Yes, sir.
Right. Now, so the next operation which we are going to perform on binary search tree is nothing but finding maximum and minimum element in binary search tree. So I want to implement a program to find maximum and minimum element in the binary search tree. If you take our previous program, sir, tell me what is the minimum element in this binary search tree? Please confirm. What is the minimum element?
1,
1. What is the maximum element?
10.
10.
10. Can I say the minimum element is available always in the leftmost side of the binary search tree? Correct?
Yes.
Am I right? And the maximum element will be present always at right side of the binary search tree. Am I right?
Yeah, yes.
Correct? So we are not required to travel the entire tree. We are not required to travel the entire tree. You can search in its left part or we can search in right part. Correct?
Yes.
Correct. Am I right?
Yeah,
Yes.
yes.
So now what we have to do, if I want to find out minimum element and if I want to find out maximum element, so I'm going to define one method like find so minimum. Okay, find minimum. Better I will take, okay, find minimum, find min and find max, like this I will take. So no arguments are required. It is going to return minimum object and maximum object. Now observe. Sir, first I want to find out minimum object. I am defining one static method. So it is going to return integer. So find min is the function. So of course it is taking one parameter called node. One parameter called node. So let us pass here. We are going to pass a tree dot root. In the next example also, we have to pass a tree dot root. Now what we are doing? Sir, first step, if a node is equal to null, that means if the tree is empty, tell me what is the minimum value? Already I told integer dot max underscore value. Am I right? Correct? If
Yes,
there
sir.
is no tree, what is the minimum value? Integer
Max.
maximum I am
Yeah.
taking. So next, otherwise, so what is the initial value of node? 6, right? Correct?
Yeah.
Dot left is not equal to null. Now check. What is the 6 left node? Come on, speak. What is the left node of 6 in the tree? It is 4. It is not equal to null, right? So what we have to do? Node is equal to node dot left. So previously the value of node is 6. Since it is not equal to null, your node will become 4. Left side only we are traveling. It is also not equal to null, it will come here. It is also not equal to null left side, so it will come here. But its left side is null, right? So the loop is going to stop. Can I return node dot data, which is going to return the current node data, which is nothing but 1, for to find minimum value. If I want to find out maximum value, if the tree is empty, I will return minimum value, and we have to traverse towards right side. We have to traverse towards right side. That's all. Now if I execute, the minimum element and the maximum element present in the tree, which is nothing but 1 and 10, it is going to print. I hope everyone got clarity how to calculate minimum and maximum element in binary search tree. Do you have any queries, friends? Up to this, whatever I covered, please confirm. Any queries?
No, sir.
Right. Sir, please be active. If you are like this, just I will skip some topics. So what is the next operation that we are going to do is the given tree, the given tree is binary search tree or not, we have to check whether the given tree is binary search tree. Sir, every tree is a binary search tree, no, right? So that's why we have to implement a program to check whether it is a binary search tree or not. It is a some kind of a logical operation. So just we will return true or false if it is binary search tree or not. Now I am defining one method like a static boolean is BST is the method name, which is going to take some node here. Okay, assume for your convenient purpose, I am taking one tree like 10. Its left child is a 20. Its right child is a 30. So let me take here 80 and here I will take 40. Now tell me, sir, is it a binary search tree or not? Please confirm. Is this tree is binary search tree or not? Please confirm.
Yes.
Yes. So this method has to return true. Am I right?
Yes.
So how it is going to work? Very simple. If the node is equal to null, tell me, is it a binary search tree or not? If the tree is not there,
True.
can I say return true? See, if there is empty tree, it is a binary search tree only, right?
Okay.
Okay. Now, so if node dot left is not equal to null, that means what? Left child is there. Okay, left child is there. Sir, left child is there or not? Yes. At the same time, so I am trying to find out maximum, not maximum element, or let me find out maximum element in left child. Sir, observe carefully. So the node is nothing but what? 40. In this 40, in its left child, we are trying to find out maximum element. Sir, in its left child, what is the maximum element? 20, correct? Or let me take the above tree. Now the node is nothing but this one. So in this entire subtree, I am trying to find out maximum value. What is the maximum value? Please confirm. 5. Sir, this 5 is greater than the node dot data, means what we have to return false, correct, sir? What is the property of binary search tree? Every element should be less than the root node in the right left side. So the elements present in the right side should be greater than root node. Now root node is a 6. I am trying to find out the maximum element in its left side, which is nothing but 5. This 5 should be less than 6, right? If it is less than 6, then it is a binary search tree. Suppose if it
Yes.
is greater than 6, it is not binary search tree. Got it?
Yes, sir.
Can I say same thing? No, madam, please be active, madam, because anyway no one is responding. At least if you respond, I will continue. So if node dot right is not equal to null, and we are finding which element? Minimum. So in it which side? In its right side we will find out. So if it is less than node dot data, then what we have to do? We have to return false, correct? Otherwise, what is the next one? Is BST of node dot left and is BST of node dot write. I am checking in its left child and right child. So when it will return true, when node is equal to null, like that it will consider. Got it? Now, so tell me, is this a given tree? Is it a binary search tree or not? Yes, let me check. BST dot is BST of node dot or tree dot root. I am passing. My expected output is nothing but what? True. Now consider I am creating one more tree, sir, like BST. So tree 2 or tree 1 is equal to, so new binary search tree. So tree 1 dot insert node. Okay, or because if you insert it will add according to the order only, right? So root is equal to, so new node of I am taking 10. Okay, so under its left child is nothing but I am taking 20 and its right child is nothing but I am taking 30. Definitely it is not a binary search tree. If you want, you can see. So the output which I am expecting is false. Root 1, tree 1 dot root. Now I am expecting the result as nothing but what? False. Let me check. Yes. So if you make 20 as the root node, 10 as the left subtree, 30 as the right subtree, then what will happen? So true. Suppose if you make 30 as the left subtree and 10 as the right subtree, it is a tree, but it is not binary search tree. So I hope how to check whether the given tree is binary search tree or not, you people got very clear clarity. Do you have any doubt in the code? Please confirm.
No, sir.
Right. Now I am discussing a very important topic. Okay, a very important topic. Please concentrate well. What is this operation? Is deleting a node from binary search tree. Sir, how to delete a node? Sir, it is very easy to delete a node from binary search tree. But the problem is, if you delete the node, okay, if you delete the node from binary search tree, remaining nodes also get disturbed. Okay, because assume in this diagram, I want to remove 6. If you remove 6, then okay. But which node should come to the position of 6 is very, very important. So that's why we have to write a special code for that. There are 3 cases will be there. What is the first case? Is deleting a node. Deleting a node which is having or which is not having any children or any child nodes. Sir, if a node is not having any child nodes, it is very simple to delete. What is the second case? Suppose if a node is having or deleting a node which is having only one child. So within bracket either left or right. In this example, if I want to delete 10, it is very simple. If I want to delete 1, it is very simple. If I want to delete 9, if you delete 9, what will happen? So there is only one child. In such a case, so who is going to become that particular position? And what is the third case? Deleting a node, so which is having both children, like how you are going to delete. These 3 cases are very, very important. Even in the interview also, minimum some 5 to 6 times they are going to ask this question. Keep on, they will give one simple what you can call one tree structure. They will ask you to delete one node. Can you please write a code for that? Like that there may be a chance of asking the question. So clear, guys, up to this?
Yes, sir.
Yes.
So now we will see how to perform this delete operation. For this, the code level order traversal. Here I am going to call so tree dot delete node. Sir, you need to pass some node. For example, in this case I am passing 1. That means I want to delete the node called 1. What is the method I am taking? Can I take void? Sir, how you are calling? By using tree object only. So void return type, method name is delete node. I am passing simply data. What I will do, root is equal to, again delete node I am calling, by passing root comma, from this root you have to delete this node. Now node, so delete node, which is taking the node object as well as the data. Sir, if I want to delete, first we have to search where it is. Am I right? If you want to delete, we have to search where it is. Correct?
Yes.
Yes, sir.
Now what I will do, how to search? If node dot data is less than the data which you want to delete, then where the node is available? In its left child, correct? Or in its right child?
Left.
Oh, right, I think so. The data which you are searching is greater, means what? It is available in the right side. Am I right?
Yeah, yes.
Now, so I am going to search in right side. Suppose the node dot data, that means root node value, is greater than, so the data which you are searching, can I say it is available in the left side?
Left side, yeah.
So we will repeat this process. Okay, so how it is going to work? Observe carefully. I want to delete 1. First, this is the node. Sir, is this node data 6? Is it less than 1? No. Is 6 is greater than 1? Yes. Then it will come here. This is my node. So is 4 is less than 1? No. Is 4 is greater than 1? Yes, in its left chain. Sir, is 2 is less than 1? No. Is 2 is greater than 1? Yes, it will come here. So is 1 is less than 1? False. Is 1 is greater than 1? False. That means what? We came to the position where we need to delete. Up to this clear?
Yes.
Now tell me, who is the left child for 1?
Null.
Who is the right child for 1?
Null.
Can I use here, if node dot left is equal to null and node dot right is equal to null? That means what? There is no children, right?
No children.
In such cases, can I return null? That means what? Case 1, if no child. Because we need to delete this, right? So who is calling? Previously this one is calling. In such places I am going to return null. That means this entire object will be now pointing to null. Got it, friends?
Yes.
Yeah, yes.
And at last, can I return that node? Because then only it will attach, right? Because who is calling? For that it will attach. Correct? Now observe. So is the node 1 got deleted or not? If you want to check, better after this delete, I will print. Now execute the code and check whether 1 is deleted or not. So after deleting 1, 6, 4, 8, 2, 5, 7, 9, okay, 3, 10. But before that, 1 is there. Got it, friends?
Yes.
Everyone understood?
Yes.
Yes, sir.
Sir, okay, fine. I want to delete the node 9. Okay. So in such cases, what we need to do? If I want to delete 9, so we know very clearly how the pointer will come up to this. When it will stop, can I say after getting node here, it will stop, correct? Now, what is the if condition? Case 1 is node dot left. 9 left node is null. Yes. But right node is not null, right? So then what we have to do? If node dot left is not equal to null. So what we have to do? Else if node dot right is not equal to null. In this case, node is nothing but what? 9. Is it left child is not equal to null? No, sir. Is it right child is not equal to null? Yes, its right child is existed. So what I will do is node dot left I am going to return. Otherwise, better I will take equal to. Tell me, is node dot left is null?
Yes.
Right. Then which node will become parent? Can I return node dot right side? If right is equal to null, can I return left? Please confirm. Node dot left is equal to null. Then right side node will become the parent. If right is equal to null, the node which is having left side will become parent. Sir, what will happen if both are not there? That case is already covered. Correct?
Hmm.
Clear? So if all these three conditions are not satisfied, then what is the meaning?
Both childs are there.
Case 3. So both children are existed. Correct?
Hmm.
Now let me check. So whether 9 got removed or not, let me check. If 9 is removed, in the place of 9, which node should come? 10. Correct?
Yes.
Clear, everyone?
Yeah, yes, sir.
Right. Now, so I want to delete a node called 2. Now
Hmm.
tell me, for node 2, how many children are there? 2 children.
2.
Which one should become parent?
Left.
Left.
1.
One can become parent.
Whichever is smaller.
Correct. Suppose consider I want to delete 4. As per your rule, which is a small 1? 1 should not come, right?
No. 2. If we delete 4, then 2 will come.
Okay.
2 is
If
immediate now.
if you delete 4, in the place of 4, which node you are expecting?
2.
5.
If you take 2, 1 and 3 are there left side of 2, correct?
Hmm.
But 3 is less than 2. Condition false, right? Are you getting? So that rule won't work. Suppose if you take 5, in this case it will work. But if I delete 6, in the place of 6, which node you need to bring?
Oh, no.
8.
If you bring 8, you have to move 7 to the left side, correct?
Yes.
So it is a complicated issue, right?
Hmm.
What I will do is try to write in order for this tree. Tell me what is the in order? 1
1,
followed by 2,
2,
followed by 3,
3,
followed by 4,
4,
followed by 5,
5,
5,
followed by 6,
6,
followed by 7,
7,
followed by 8,
8,
and then 9, and then
10.
10. Correct? See,
Yes.
whenever you are deleting any node having 2 children, okay, immediate in order successor you have to take. This is in order, right? Successor means what? Next node. Suppose I want to delete 6. Which node will become parent?
7.
Now it will work, right?
Hmm.
There is no problem, correct?
Yes.
Suppose I want to delete 4. Which node we have to bring as a parent? 5.
5,
Suppose I want to delete 2. Which one will become parent? 3.
3,
I want to delete 8. Which one will become parent? 9.
9.
Why I am taking only in order successor in the sense, observe carefully, for any node, okay, for any node in order, sir, if you take 6, the leftmost element, minimum element will come immediately. Got it? If you move this as a parent, all the elements will be greater than this one only, right?
Yes.
Yeah, yes.
Understood?
Hmm.
This technique we will use. Now, which one we have to find out? In order successor, correct?
Hmm.
How to find out in order successor? Suppose if you take the node 6, in order successor means minimum value in that node dot right. Am I right?
Yes.
Yes.
Now I am writing one separate code only for utility purpose. Static, which will return node, find in order, find in order successor for any node, for any node. How to find out in order successor? Observe carefully. Until its node dot left child is not equal to null, we will keep on moving to the left. This logic I already covered. At last I am writing the node, correct?
Hmm.
Yes.
Now, what is a code here? Very simple. Node in order successor is equal to find in order successor. Okay, find in order successor of which one? Can I say node dot right?
Mm.
Which node you are trying to delete in its right side? What is the
Hmm.
minimum value?
Yes.
Now observe carefully. Node dot data is equal to, can I take in order successor dot data? What is the in order successor that we got in this example? Sir, it is a 7. Can I update this node with 7?
Hmm.
After updating, what we have to do? We need to delete this, right?
Hmm.
So just I performed copying only. Now what I will do is, again I am going to call node dot right side is equal to, can you please delete from the node dot right? Okay, so in order successor dot data, I am deleting. So again same method will invoke. So now 7 is having any children? No, right?
No.
Then automatically it is going to return. Got it?
Last line, can you tell again, sir? Node dot right.
Madam, we are copying the 7 to this position. That means 6 got deleted. But 2 7s are there right in the tree.
We will delete.
Whatever we have copied, that we have to delete. Where it is available? In its right side only, right? For the node right side part only, this diagram round. For that, I am attaching, I am calling delete function. In its right side, can you please delete in order successor data? What is the data? 7, right? It is a variable. So that 7, can you please delete from the right side? Not root node. In its right side, it
Okay.
will delete this. Got it?
Yes.
Now, so I will execute this code by deleting multiple nodes. You will get clarity. Now observe carefully. First I am trying to delete 2. If you delete 2, in that place, which node should come? 3. In line number 129, node dot right is equal to, what is the method name? Delete node. Now see, in the place of 2, 3 came or not? Suppose if I am deleting 4, in the place of 4, which node should come? 5. In the place of 4, the node 5 came. If I delete 8, in the place of 8, which node should come? 9. Correct?
Yes.
Now if I delete root node 6, then 7. Got it?
7.
Clear everyone?
Yes.
This is the way how to delete an element from binary search tree, which is very, very important and a complicated thing. Clear, guys?
Yes.
Any questions from this?
No, sir.
Right. If you are clear, I will move to the next concept. Clear up to this?
Sir, one point, like if this logic of when we are deleting any node, we are
Hmm.
immediately pointing to the node which we are deleting will be replaced by immediate in order successor. So this logic is like, what is the purpose of this? It will just create another tree which is balanced. That's it, right?
No, sir.
Another binary tree which is like,
See, first point, it is not creating, just we are changing that nodes. So the root node is 6, right?
mm-hmm.
That 6 data we are updating to 7.
Mm-hmm.
Then already 7 is there in the right side of 6.
Mm-hmm. Yes.
That we have to delete because duplicates are not there.
Okay.
Got it?
Yeah, like yeah, like I was just thinking, like why this kind of rule is there that only immediate in
There is no other alternative option. I told you, you missed that logic. If you take in order successor or any tree, you can take binary search tree. If you are trying to delete any node in its left child and right child, again readjustments we have to do. Correct?
correct.
But that readjustment will create an issue because every node we have to shuffle, right?
Oh, yes.
What is the alternative? What I am telling is, if you want to delete any node, for example, 6, I want to delete. Try to look over this right side. Right side, try to find out the minimum element.
Mm-hmm. Okay. Mm-hmm.
If you move that minimum element to this position, no need to disturb this tree, right?
Yes.
How to get that minimum value? If you write in order successor, so you will get minimum element after this.
Got it. So like it is an optimized approach rather than shuffling in every three, like all
Yes,
the nodes.
exactly.
Got it.
Sir, we have different approaches, but this is the only approach which we will use.
Clear, sir.
Can I use one word? If you are having any tree, some people are going to ask in the interview, especially in lead code, can you please print the data in the tree in ascending order? So people are going to think, Array sir told different programs, but sir didn't cover that sorting algorithms. But nothing is there. If you print in order for the tree, it will be in order only, right? Correct?
Yes.
That's all. These are the small loopholes, sir. Beyond that, nothing. Clear? Everyone.
Yes, sir.
Right. So the next operation, which I'm going to demonstrate now. So the next one is remove all leaf nodes from binary search tree. I want to remove leaf nodes from the binary search. So how to remove all the nodes? Sir, tell me in this tree, whatever I have shown, which are the leaf nodes?
1, 3, 10.
1, 3, 7,
9,
10.
yes.
Yeah, 1, 3, 5, 7, 10. Can I say the node is said to be leaf node if it is not having any left and right child? Correct?
Yes.
So keeping that in our point of view, we can delete. For example, tree dot. So delete leaf nodes. No need to pass any argument, but if you want, better to pass a tree dot root. So we have to define this delete leaf nodes method. Let me take void as the return type, or so delete leaf nodes. We are going to pass node dot node. Better you will take it as a node. I will assign because reference is very important. That's why. Otherwise, you can create one utility method like what we have done in the previous case. Now, what I am doing is, if node is equal to null, directly can I return null?
Yes.
Sir, if node dot left child is null and node dot right child is null, in such a case, can I return null? Same case. We are deleting the node which is having no children. Got it?
Yes.
So otherwise, what we have to do? Same process. We have to repeat for node dot left is equal to. So delete leaf node. Delete leaf nodes of node dot left I am taking. Okay. And delete leaf nodes of node dot right I am taking. Got it? And at last I am going to return the node. Got it, friends? Nothing is there. If left and right are null, then I am returning null. If left is not null and right is not null, I am keep on moving. Got it?
Yes.
Now observe, really is the node got deleted or not? Let me check. So initially 64825791310. Now 648. So 2 is there, but 5 is not there. Why? Because it is a leaf node. 7 is not there. 9 is there. And 1, 3, 10 got removed. Got it? So everyone got clarity how to remove the leaf nodes.
Yes, sir.
A simple approach, whatever we applied in the previous case. Clear?
Yes, sir.
Yeah, just wait for 1 minute. Please wait. Yeah, sir, up to this clear, right? Please confirm so that we will move for the next one. Up to this, no doubt, right?
Yes, sir.
Right. So let us go for the next operation. What is that operation is print in range. So this is also one of the lead code challenge what we have. So they are going to give two numbers. What is your task is you have to print list of nodes. We have to print list of nodes whose values are in between k1 and k2. So what is k1? The first argument. What is k2? The second argument. In between that, what nodes are there? We have to print that entire list. For example, in this program, if k1 is okay, if k1 is for example 3, then k2 is something like 8. Tell me which nodes are available in between. So 3, 4, 5, so 6, 7, 8. These nodes we have to print. Understood? Is the target is clear? Please
Yes, sir.
confirm.
Yes, sir.
So how to implement this? Sir, in the main program, just I am trying to print obj dot, that is a tree dot. So print in range function I am going to take, where tree dot root node is the input. Assume the first node is 5, second node is nothing but 15. In between this, which nodes are there, we have to print. What is the name of the method that we are supposed to implement? So void print range, which is taking the node and integer k1, integer k2. How to print? Listen carefully. If node is equal to null, can I stop this process? Because if there is no tree, nothing will be there. Am I right?
Yes.
Yes.
Otherwise, if the node dot data is greater than or equal to k1 and node dot data is less than or equal to k2. So what we are doing in these cases, we have to print. But before printing, So you need to take left side also, right? Like print in range of node dot left comma k1 comma k2. Similarly, node dot right k1 comma k2. So after this, system dot out dot print of node dot data followed by some space. Observe carefully. In this example, I have given 5 and then 15. Sir, first k1 is a 5, k2 is a 15. So the node is initially 6. Is the node value is greater than or equal to 5? Yes. Is it less than or equal to 15? Yes. Now try to call this function for this one and print this node data and try to call for this. Sir, immediately it won't print 6. But before that left side call is there, right? It will print from the left side and it will print. Got it, sir? It is something like in order. First left, then printing of data, then right. So left side also, again left, printing of data, right side. Clear, sir? Everyone, please confirm.
Yes.
And there is one more case that we need to cover. Suppose consider I have given the node data, I mean left side data as a 7 or left side data as a 1, right side data as a 4. Sir, then is there any chance of existing the values in the right subtree? No, right? Are you getting my point? If k1 is 1, k2 is 5, is there any chance of getting the data in the right subtree? No.
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 In such cases, else if node dot data is less than k1, then what we have to do? We have to call that print range function by searching only in its left side. Otherwise, we have to search only in right side. Got it, friends?
Hmm.
Yeah.
Yes.
Now let us see whether it is going to print all the data. Yes. 6, 7, 8, 9, 10. Let me give the values like so 1 and then 5. Really, is it printing only in left side? Sir, is it printing? No.
Mhm.
1 and then 5. Why it is not printing? Can you please cross check? What is the node value that we have given? This one. What is the range that we passed? 1 comma 5, k1 and then k2. Now check the condition. Node 6, is it greater than or equal to 1? Yes. So 6, is it less than or equal to 5? No. Then node dot data 6, is it less than 1? No. 6, is it greater than 1? Yes. We are printing in its right side. But actually it is present in the left side, right?
Hmm.
Now let me try. Is it printing?
Yeah.
Yeah.
Let me give 9 and then 15. 9 and then 15. Where it should print? In the right side. Correct? So perfectly working. Any queries?
No, sir.
No.
So how to print in the range? Clear, right?
Yes.
Now. So what is the next operation that we are going to discuss here is root to leaf path. We have to print root to leaf. All the paths we are required to print. So how to print that? Just I will use one method. What is a method is tree dot print root to leaf. So I'm passing tree dot root node, and I will pass a new array list of holding integer objects because I want to print in the form of a list. So what I will do is I am implementing one static method. The return type is void print root to leaf node and one array list object I am receiving. The name of the array list object is path. Now observe. Sir, first time my array list is empty. My array list is empty. What we need to do? If node is double equal to null, don't do any activity. If node is equal to null, don't do any activity. Otherwise, path dot, can you please add that node dot data? As of now, what is the node? 6. What is its data? 6. We are adding. After this, what we have to do? We need to check the left side, right? Suppose for that node, if left is null and right is null, what is the meaning of this? We came to the last, correct? If both are null means we came to the bottom. Am I right? Then I'm printing that total path. Later I will write code for that. Sir, it is not reached to the ending. Then what we have to do? Recursive method. So print root to leaf by passing node dot left comma that path. So node dot right comma that path. Now what will happen? It will first it will add 6, left side it will add 4, left side it will add 2, left side it will add 1. Sir, is it reached to the ending or not? Please confirm.
Yes, sir.
That means it is a path. This is the first path, correct?
Yes.
Then come back. Sir, can I say when we are going back, path dot remove of path dot size minus 1. I am removing 1. Then what I will do? Right side, I will add 3. So we came to the ending. 6, 4, 2, 3 is the another path. Then it will remove 3. Then it will remove 2. Then it is going to add 5. We came to the ending. 6, 4, 5 is the another path. Then it will remove 5. Then 4. Then it will add 8. Like that, it is going to print. Got it, friends? Now, which method we have to implement for this? Static void. So print path is there, which is going to take one array list object holding integer values. Path is there. What we need to do here? For integer I is equal to 0, I less than path dot size, I plus plus, system dot out dot print of path dot get of I am printing that value followed by some arrow mark. That's all. So that the total path it is going to print. And at last term, let me print null, which indicates there is no next paths. Now for this tree, it will print root to leaf, every path. 6, 4, 2, 1. This is one path. 6, 4, 2, 3, another path. 6, 4, 5, 6, 8, 7, 6, 8, 9, 10. Like this it is going to print. Clear, guys?
Yes, sir.
Any queries up to this?
No, sir.
Right.